that provide the same information as the minerals from yesterday, except about uranium. So if you're interested in that, hold off from the coffee for a couple of minutes, and we have an impromptu bit of expert information about uranium, which you might want to know. And then we have a special announcement right before we get going.
Yes, thank you. Just a little thing, you have tomorrow morning, you have to leave your bedroom before 10 o'clock, okay, and put your luggage just here, okay? Tomorrow morning, okay? Second thing, your badge, tomorrow morning also, please put it in the little basket behind the blackboard, okay? Thank you very much.
Right, but you have to come to my talk at 9. Don't be packing. Get organized. Get yourself together. All right, our first speaker, we're ready, is Stephane Zuber from the Paris School of Economics. All right.
Thank you. So thank you for the invitation. As you can see, I was asked to talk about discount rates. And actually, I think my talk will be somewhat different from other talks in this week, because it will be mostly about some kind of economic methodology, how we use the discount rate and what is the discount rate and how we choose a discount rate. And also a little bit about some of the debates that exist in the economic theory around this notion, and which were quite intense in recent years, actually. So discounting is a very important thing in economic methodology, in particular when you are some intertemporal economic analysis. So the main issue here is that you have some to evaluate something which has some current cost or benefit and some future cost and benefit, and you want to be able to, in a sense, compare these costs and benefits which occurs in different periods. So the question, in a sense, is to give some price or some value to this future cost, and this is, of course, crucial for the evaluation of many policies, or for energy policy, for instance, but also for policies dealing with climate change more generally. So this is really a central tool in this kind of economic analysis. And throughout the presentation, I will very often come to this example, which is a quite typical example of the use of discount rate, which is the social cost of carbon, how we compute the social cost of carbon and how the discount rate might affect that. So as you will see, discounting in that case is very important. Okay, and so when you think of this topic, what you see in the economic literature is that there were very huge debates about the notion of discount rates recently. So in a sense, it started with the Stern Review. So the Stern Review was something that was commissioned by the UK government just to evaluate climate policies. And actually, one of the conclusions of the Stern Review was to prompt strong action to prevent climate change. Okay, and actually, this conclusion was, in a sense, at odds with the mainstream, if you want, economic wisdom at the time, and in particular, one famous economist called Nordhaus wrote several papers about this issue. And on the contrary to the Stern Review, he recommended a more gradual response to emission reduction in a sense. So actually, one of the differences between the two analyses, if you want, is really the discount rate. And that's what people realize. It turned out that there were not so much differences in the way you evaluate future cost or this kind of issue or the efficiency of the technology that you use. It was one of the main issues was the discount rate. And actually, Nordhaus and Stern have very different interpretation of the key parameters of the discount rate. And that's how they come up with very different values for this parameter. Okay, so what I will do in this talk is to address some issues. So I will try to argue that there is some ambiguity about what we call discounting and the use of discount rates. And actually, you find that in the literature, in the economic literature. people use the discount rate in many different ways. And I think we need to be clear about what we are talking about. So I will try to show you what are different kind of definition that you can have, and this of course has an impact on the kind of economic analysis that you can do. Then I will come to this very hot debate, which is what is the value of the discount rate. So I won't come up with a solution to that, because I don't think there is a straightforward solution to that, but I will try to tell you first that, of course, the analysis is very sensitive to the parameter, and then also to try to reconstruct the position of Stern and Nordos and tell you what we can say about that. Then I will come to some other very difficult issues. So one of the very difficult issues that we have is, of course, uncertainty, which is something which is everywhere when you evaluate future policy with future impacts, future costs, or future benefits. And I will tell you that it also affects the value of the discount rate, and there were some recent papers on that in the economic literature, in particular this quite famous paper now in economic analysis, which is the Weizmann paper, where he proposed a decimal theorem, and I will tell you what this decimal theorem, just saying that in a sense you cannot use a discount rate, but I will also discuss that. So this is the plan. So I will just first come with this definition issue, so just try to show you how we use the discount rate in economic analysis, and try to give some of the definitions that are used. Then I will come to the Nordos-Stern debate, which is what these controversies about the exact value of the social discount rates. What can we say about that? And then I will come to the difficult issues, difficult remaining issues, which are those pertaining to the existence of risk or uncertainty, and also equity. And I will also point some additional issues, but we don't know much about that at the moment. Okay, so what's the use of a discount rate? So the discount rate, the reason why we use that is just to compute what we call a present value, or sometimes net present value when you have costs and benefits. So you want to evaluate a project of a policy which has some impact in different periods, and you will calculate this present value of the benefits or cost of the policy. So you have the project, you have some benefits for each period, and the present value is just this weighted sum. And so the important term here is, of course, this term here with this row, and the row is the discount rate. So what this formula tells you is that you will aggregate the cost and benefit across time using this weighting scheme. And the weighting scheme, one of the key elements of the weighting scheme is, of course, the discount rate. In general, you put less value or less weight on the benefits or costs that occurs tomorrow than to the costs that occur today. Okay, so that's the general use of discount rate, if you want. So if the present value is positive, it will tell you that you want to do this project, that the policy or the project is worth be implemented. And so now, what is the definition? Why do we use this discount rate? So, and actually, I think so. There is a recent paper where they make a distinction between two approaches to discounting, and I think it's a useful distinction. So you have kind of an investment approach to discounting and a consumption approach to discounting. Yeah?
Is there a mathematical basis for justifying that it's exponential in time and not something else, so algebraic or something like that?
No, there is no reason for that. So no mathematical reason for that. So that's just a way of writing the price, and the reason we write if you want the exponential to the power of power minus root is like a PT, like a price of the future good. And the reason why we write the price in this way has to do with one interpretation of the discount rate, which comes from more the investment side, where you have some interest rates. And usually the interest rate has this property of having this kind of exponential formula.
The translation of the taux d'amortissement?
Yeah, it's like a taux d'amortissement or taux d'intérêt. So it's just like it's conceptually similar to an interest rate or something like that. But what you can take from that is that actually what is important is, in a sense, it's price. So we write it in this exponential, with this exponential formula, but the important thing is that it's a price of the future community. It's something that translates future benefits or costs in current ones. Okay. Okay, so I'll now come to these two views or approaches to discounting. So one approach is what you can call the investment approach. And the investment approach just tells you that you can invest money today, and you will have some return on the what you invest today, and therefore, if you invest €1 today, you will have more tomorrow, and that's just this phenomenon that you want to in a sense represent in discounting thing by just saying that the euro that you spend today, you can also invest it, and it will give you some more value tomorrow. So it's the basic idea behind this investment approach. So in a sense, when you have this kind of approach, what discounting is doing is kind of ranking different projects. So if you consider a given project and you discount it using market rates, what you do in a sense is to see whether it's the return, the investment you are making now is better or not better than just investing the money in a market asset, in a sense. So it's just like an opportunity cost of making this investment rather than a standard market investment. One other reason why you discount is, of course, you may have to borrow some money to invest today, and just this discounting formula will just tell you that you will have to reimburse what you have borrowed, and it's worth doing the investment only if you have some more return on the investment than what you will have to borrow to make the investment. Okay, so that's a general, if you want, investment view on the discount rate. Now we'll come to the consumption approach, which is actually in policy, if you consider policy making is more relevant, and I will tell you why in a moment. So actually the consumption approach tells you that it's more valuable, it's socially more valuable to consume something today than to consume it tomorrow. Okay. Than increasing the consumption tomorrow. And there are many reasons for that. I will come in detail to the different reasons you can have for that. So one reason is that future generations may be richer. So if they are richer, you may think that it's not so much worth doing some transfer to the future generation rather than consuming it today when you're poorer. Another reason is that the future generation may not exist, so the existence of the future generation is uncertain. Another reason is that the society has a pure preference for consuming today. So it's just that we do prefer consumption today, to be sure that we consume, that just having some consumption tomorrow. So these are different reasons why you have this consumption discount rate, in a sense. So one famous result, if you want, of the standard economic analysis is that the two approaches may converge under very specific circumstances. And one of these circumstances is that markets are perfect and complete. So we know from Gail's talk that it's not the case, but that's still an argument which is much used in the literature. So just saying that if the markets are perfect and complete, and if the representative agent approach is appropriate to evaluate, to determine society's preference, to make this kind of arbitrage between today's consumption and tomorrow's consumption, well, then you use the same discount rate. So the investment discount rate, so the market rate, is just the social discount rate, if you want. So the two are just the same. But once again, this occurs only in this very specific case with perfect markets and complete markets. And also the second point, which is perhaps less obvious for economists in a sense, is that you have to accept that the representative approach is the right approach to make this kind of intertemporal, if you want, assessment. Okay, so I come to the example now of how we use the methodology, and one example is the social cost of carbon. So the social cost of carbon is just a present value, so it's the present value of the damages of emitting 1 additional ton of carbon dioxide. Okay, so you have some evaluation of what the damages will be, and you just do this, compute this present value, and this is the social discount rate. The social discount rate is just that. And of course, once again, this social discount rate, this social cost of carbon, sorry, is very sensitive to the choice of a discount rate. Okay, so it's much so. If you take just to repeat myself, so if you have this profile of damages, so I just take it from a specific model, the DICE model. I'm not committing to anything about this model, but that's just that the data are very easily available, so that's why I use that to illustrate that. So if you have this profile of damages, what you will do is to just compute the present value by computing this. So this is, oh, sorry. So it's just dollar per for each year, the dollar dollar evaluation of the damage. So how much you lose from emitting 1 additional ton of carbon dioxide. So if I emit 1 more ton of carbon dioxide, I will have this impact in each period. So I will lose that in terms of consumption. Okay? So that's per year, and it's in dollar value.
And that's time?
And that's time. Yeah, so you have 400 years. So you emit, you emit today. So today is 0. Okay, so time 0, and then you go along this time axis, and you have this.
The damage in 400 years.
Yes.
Doesn't mean anything.
In what do you say? It doesn't.
What do you know? What is the damage in 400 years?
So you mean that the damage is uncertain? Yeah. So I agree with you. No, I completely agree with you. But I will come back to this. I'm not saying that it's a right evaluation of the damage. Once again, I'm not committed to this model, and I agree with you that there are huge uncertainties about the damage. I will talk about that later. But yes?
Did you say it's the marginal cost?
It's the cost of a marginal emission, of the emission of a marginal ton of carbon.
It's the annual loss.
Yes.
It means that in 1 century you will lose $1 per year.
Yeah.
In 2 centuries you will lose 6
Exactly.
per year.
Yes. Yes, exactly.
Can I make a very quick remark? It's written that ton of carbon, and you say ton of CO2.
Yeah,
It's not the same.
no.
It's
I made a mistake.
Yes.
Yes.
But economists sometimes are confused.
Yeah, you're right.
In fact, 3.7 between the two.
Yes.
You
No.
better know that.
Yeah, I agree with you.
I'm sure you know, but
No.
you say CO2 and it's written carbon.
Yes, Okay, so.
We need to continue.
Sorry?
We sort of need to continue and ask more questions. You said it's an example.
No, but if there are clarifying questions, so it's just an example. So, well, I'm not saying that it tells us anything relevant, but it's just, well, it tells us something, but I'm not saying that it's the right way to evaluate these damages. No? Right. Okay. It's just, my point was just to give you that, how sensitive this is to the discount rate. So just taking this profile, when you aggregate things, well, you have completely different things. So the standard one would be 4%, so market rate discounting. So if you have that with the specific damage that...
SEC is the integral of the previous curve.
Yes, the weighted sum, so the integral, yeah, of course.
How many years?
Was infinite.
Infinite.
Nearly infinity. So
Yes. Well, it matters a lot for this one. It doesn't matter at all for the 1%. So you can just cut at the 400 years. For this one, it's very sensitive to that. So that's why we have this 4,000 something number, which is a huge number for social cost of carbon. But yeah, you can see that. Well, it's. I mean, yes.
that's per ton.
Yes.
To So 1 ton would be $4,000.
Yeah. Yeah. Okay, so just to illustrate that, well, how you use the methodology and how important the discount rate is, and I'll just give you some of the numbers that are used in some countries, and you see that there are also huge differences, and some of the differences between the different countries is that they actually use different discount rates. I will tell you a little bit later that actually in the UK and in France we use what we call declining discount rate. I will tell you why we can do that and why we may do that. In the US it's just a flat discount rate that is used, and which is actually higher than the one that the UK or France use. Okay. Okay, so what's the use of carbon tax from the economic point of view? So from the economic point of view, the way we use the social cost of carbon, is to, one way we use it is to just design what we call a carbon tax, or something that is not called a carbon tax when the public don't like the name, but something similar. So it's what we call a Pigouvian tax. So a Pigouvian tax is something that helps you dealing with some externality. So there is some effect of your consumption or your behavior that has some impacts on people around you, but which is not something that markets take into account. So if markets don't take that into account, you should take it into account in some way, and that's what the Pigouvian tax is doing. It's just making you pay for this externality. Okay, so if the price of the externality is just the social cost of carbon, the carbon tax should be equal to this social cost of carbon. So that's one of the standard application of this social cost of carbon. More generally, you use it when you want to evaluate abatement policies. So you can just look whether the present value of a given policy is greater or less of all the social costs of carbon. So if what you gain by making the abatement policy is larger than what you have in terms of damage, which will not occur in the future. Okay, so and there are some examples like that. So this is like a study by McKinsey. So once again, I'm not committed to their numbers. So where they evaluate the present value of different abatement policies. And you can compare that to the social cost of carbon. So here you have some work on building structure and stuff like that, where you can improve. Actually, you have a negative present value, which means that you have more money when you do this this kind of policy. So you even don't have to ask the question whether you should do that or not, because you will gain money if you do all this kind of policy. And then you have some much more costly policies, and if you have a given number for the social cost of carbon, you will first do this kind of policy and then go up and up until you reach the social cost of carbon, and then you stop because it's not worth doing the policy anymore. Okay, so that's in a sense the spirit of this kind of methodology. Okay, so a brief summary of what I've said until now. So as I told you, there are in a sense two approaches to discounting, this investment approach and the consumption-based approach. So the investment approach is really relevant when you have to borrow money to have some financing of the project. So it's important to see whether it's worth doing it. For public policy, what we're often looking at is just reducing consumption today to increase consumption in the future. So really making this kind of consumption arbitrage, and in that case, it's more relevant to use some kind of consumption-based approach. So that's why I will actually more focus on this approach in the remaining of the talk. The other reason is that with the investment approach, you just have to look at the market rates. So you don't have much to worry about what the right discount rates. But if you want to design policies, it's important to have this consumption discount rate to really have this evaluation from the social point of view, if you want, of the impact of the policy. So once again, the two approaches may be different, and we have all the reason to believe that they are different. So there are no reason to believe that the consumption-based discount rate should be the same as the market discount rate. Okay, and the rest, I've already talked about that. So now I focus on the social discount rate, and I will tell you how we derive this kind of social discount rate. So what I call the social discount rate is a consumption discount rate which is used at the social level in a sense. Okay, so where does it come from? So the whole social discount rate story comes from the very basic practice in economic theory, which is just to ground some kind of cost-benefit analysis, which is what I've presented to you, just assessing the cost and the benefits of a policy. So, and you can have some kind of theoretical foundation of that based on some social welfare approach. And in a sense, that's a standard way to do it, at least in the theoretical literature about the cost-benefit analysis. So what people do, actually, and you will see that's what Stern and others do, is to evaluate the consumption path using this kind of what we call a social welfare function. So that's just a function that will run different consumption paths, simply. And so what is this social welfare function? You see that it's, once again, a discounted sum of what we call the utility of individuals in different periods. So we have this discount factor on the utility, and then we have this utility function, which is something that transforms some consumption value into a utility value. So some kind of measure of welfare or well-being, or something like that.
What is the unit of utility function?
There is no unit.
It's one of the problems in economics.
It's not euros or...
So no, so that's a very complicated issue. So I will not answer that. I will not answer that in 2 minutes. But there are many different foundations of the utility numbers. So you can base that on some well-being measure. You can base that some economic, really, it can be monometric. It can be expressed in money terms.
There is no normative definition with a given unit.
There are different normative, it's more fair to say that there are different normative views, and people don't agree about that. So, but that's a very deep issue, so I can't cover that in 2 minutes. Okay, so, and then you just look at some projects. So the project is just a small perturbation. So we always assume that there is some marginal change in the consumption path. So you look at this small perturbation, like I call DCT. So you change a little bit the consumption of people in different periods. So that's the damages or the costs or the benefits of the policy, this small DT. And so what you want to look at is whether this increases social welfare, in a sense. So if the situation is better now. So to do that, you just put these differences. And well, since it's all marginal, you obtain this formula. So you have this. So the policy is worth implementing if this sum is greater or less than zero.
Scale expansion up to first order in DCT.
Yes, exactly. Because once again, we assume that this is a marginal change, and very small change, or the given consumption path. Okay, so if you denote this expression rho, you obtain something which is similar to the formula I gave you before. So you obtain that this formula, you can rewrite it if you want, like this, which is exactly the present value formula I gave you before. So it's just rewriting it this way tells you what will be, in a sense, the definition of the social discount rate in that case. And this is exactly the expression here. So it's this minus 1 over t of the log of this expression. Okay, and actually, in principle, there is no reason why this discount rate should be constant. It may depend on the time period. There is no reason why it should be independent on the consumption path, and actually it's dependent on the given consumption path you start with. So it will depend on the whole C, the whole trajectory in a sense, in principle. Okay. So just, well, I will just give you some approximation of the formula to come up with the last formula.
Yeah, 10 more minutes maybe.
Yes.
Go to Nordos instead.
Yes, okay, I will just tell you that you can rewrite it this way because this is the standard way we write it, which is called the Ramsey equation. Okay, so the Ramsey equation is just this. So you have several elements in this standard formula for discounting. So this is what we call the pure time preference parameter or the pure discounting. So this is the thing that discounts the utility of people in a sense. Then you have this elasticity of substitution, and then you have the growth rate of consumption. Okay, so these are the basic elements in the Ramsey equation. So I come to the debate between Nordos and Stern. So actually the debate is really around this formula. So both of them use the social welfare function I talked to you about. Both of them consider this Ramsey equation. So really the difference is to put some number on the different parameters. And people usually say that there are two approaches. So there is an ethical approach or normative approach, which is associated to Stern, and which say that the social welfare that we used should reflect some normative views, some views about how we should allocate utility between different generations, to make it short. And there is what is called the positive approach, which is associated to Nordos, and which is just saying that the social welfare function is just the preferences of a representative agent. And if you remember what I said earlier, the preferences of the representative agent will give you something which is the same as the market discount rates if you assume that markets are complete and everything. But this is what Nordos does, actually. Okay. So one key element on which the debate focused was this delta, so this pure time discounting element. So, and that's where the normative versus non-normative debate comes, is that Stern argued that it wasn't, we shouldn't have a large value for that. And the reason is that what this delta is doing is just putting more weight on the utility of people today than on the utility of people tomorrow. And so that this is not, this is something which go against intergenerational equity. Okay, so you have some equity, if you have some equity concern, you don't want to treat people in different ways, in different periods. Nordos just say that a pure time preference is a pure time preference. If these are the preferences of the representative agent, we should just respect these preferences. Okay. So there are problems with the two, actually with the two positions in sense. So one position, so if you come to this normative explanation, of course you have to justify why you use this specific normative view. So that's if you want one problem with the Stern approach. And another problem with the Stern approach is that the Stern report was never very clear on the choice of another parameter, which is this eta parameter here. So it's in the Ramsey equation. So this one. So it shows a very low value for that, and there is no. So which means that a low value for that means that you have a low preference for redistribution within this within the generation, if you want, which is something quite strange when you use the equity argument that Nordos uses. Okay, and the problem with the Nordos position, actually, you know what I will tell you. So, of course, you have to buy this, the fact that the market rates can be the same as the representative agent, the rate that you will obtain with a representative agent's preferences. And the other thing is that the representative agent is a very specific aggregation of preferences. And actually, you don't. Just evaluate policy using that is not really normative free or ethic free. I mean, it's a very specific position to say that this is the right way to evaluate policies. And one argument for that is that the market equilibrium is a Pareto efficient equilibrium, but there are many Pareto efficient equilibria. Why choose this one? Okay, to make it short once again. Okay, so my view is that there is some normative content in the social discount rate, and we should just acknowledge that. I mean, it's just being well, honest to say that there is some choice to be made about this social discount rate. Okay, so and what you have to do to choose a social discount rate is to try to know what people really want for this kind of long-term investment, and that's a very difficult thing, and that's why I won't come up with a proposition for the discount rate, because we don't really know how to choose this discount rate. So in the 2 remaining minutes, I will just. Thank you. For 5 minutes, 5 remaining minutes, I will just try to cover very briefly some of the other issues with the discount rate. So one issue which is actually very well known, well studied in the economic literature, is the question of the risk. So there is some risk, and this affects the social discount rate. So there are two kinds of risks that are very important in that context. So there is some risk on the level of the future consumption of people. What will the growth rate be for the future? And there is some uncertainty about the returns of the policy, which is exactly what you said. When you make some climate policy, you don't know what the damage will be tomorrow, so you don't know if you should do the policy. You don't know exactly how it will change the consumption tomorrow. So you have also this kind of uncertainty, which can affect the thing. So since I don't have time, I won't comment the details of this equation. So, but well. In the basic, if you want, the usual way to incorporate this kind of risk in the equation is to use this very specific assumption. So some power utility, which is what we always do. So it's not very specific to that case, but also some very specific growth process that we consider. So we consider usually some IID, independent process of growth with some normal distribution. And when you do that, you have this very nice formula where you have exactly the same as the usual one. So you still have your delta, your eta, so you have the average growth, and then you only have this to take into account the dispersion of the risk and the variance of the risk. Okay, so that's a very nice formula in a sense, but actually it's very specific to this kind of risk that you consider, and Weizmann provided an argument to say that if the risk that you consider has some fat tail, so if the risk of catastrophe, which is in that case a very very negative growth rate, so which can occur with some sufficiently large probability. So if that occurs, you may well end up with a discount rate which is minus infinity. Okay, so which in a sense tells you that you want to invest everything for the future, because there is so much risk in the future that you really want to change the way change the consumption of future people. So that's once again in this marginal framework where you only do marginal policies, but still it's a strong result. So the result was criticized for many reasons. So one of the reasons is that it's really related to the fact that you have what we call an infinite marginal utility in zero, so which means that you always want to give more than zero to people. The other criticism that you can have is that consumption can actually go to zero in that case, which is not really realistic in a sense. But so if you change the assumption, you won't obtain the minus infinity stuff, but you will still obtain a very negative discount rate, or you can obtain a very negative discount rate. So the result tells us something about the risk. Okay, so I will just tell you about the declining discount rate, and then I will just stop. I told you before one other limitation of the assumption that we have in this context is that we have this IID process for the growth rate. So that the growth in different periods is just independent. You cannot predict the growth tomorrow using the growth today. And if you instead use some kind of serial correlation between the growth rate, if the growth today is some predictor of the growth tomorrow, this will change the discount rate formula, and you will obtain what many people have claimed we should do is this declining discount rate. So why do we have declining discount rate, and we will decline to some lower discount rate? The reason is that when you have this correlation, you cannot. There is a huge probability that there is a negative growth path, much higher probability of this negative growth path, and this will impact the discount rate. And as I told you before, actually, that's some countries do that. So do this declining discount rate. And so this is just an illustration from a paper where they just try to estimate what this declining discount rate should be. And you see that for very long run investment, you will use, we actually use much lower discount rates. Okay, I'll stop here because otherwise I won't stop.